Good afternoon, my name is Jing and my metric number is B0918103559. Okay, what the desmodromic variable timing is short form as DVT and it's used by Ducati. Okay, what is desmodromic? This system is started by Ducati in 1956 and it's used for 125 Ducati. It's designed to overcome the problem of spring valve, and at that time it can rev up to 8000 rpm, which is very high for engines at that time. So this system uses rocker arms to control the valve. It's different from the others which uses spring. How does it works? The demodromic and DVT. So each cam have a cam lobe that control the rocker arms that's supporting the valve. So the control arm control the open and closed valve, and each valve has 2 rocker arm and 2 cam lobe. So it's for intake and exhaust cycle. That's all from me. Thank you.
What is DVT? DVT stands for desmodromic variable timing. Alright, it sounds almost same with the normal VVT like VTEM, MyVet, VVT, Vanos, but it has slight difference between the normal VVT, which normal VVT control the valve overleaf or valve lift depend on the engine speed. If the engine speed low, then the valve lift will be low. When the engine speed high, the valve lift will be high. So that's how the normal VVT works. But DVT is control the overlap, the control the valve overlap timing. So let me tell you valve overlap. Valve overlap on DVT will be open, depend on the engine rotation, engine speed. When the engine speed is at the low RPM, the valve overlap will be at the minimum. And so that's how the medium and high, at the high speed, the valve overlap will be maximum. And medium, the valve overlap at the medium stage. So what is valve overlap? Well, valve overlap meaning that both intake and exhaust valve will be open at the same time at the end of the exhaust stroke. When the piston at the top dead center will be open at that time, both of the valve. So it also varies on the engine speed. It can go low, medium, high instead of like the normal VVT and low and high only. So why using it? Because it can provide smooth power delivery, not over torque or high torque, but it also can work very efficient at the high speed and low speed RPM. So it also help to scavenging or dissipate exhaust heat much faster and better, and influence intake air fuel mixture into the engine more smoother. So that's how the DVT works. Thank you.
What is the system and technologies for the DVT? The system and technologies that DVT have is cam pulley for the housing. Next is the valve adjuster. After that is camshaft, rocker arm or the control arm, and the sensors involved in the DVT. These system and technologies are needed in order to make the DVT perform well.
Hi, my name is SASIDHARAN ARUMUGAM. I'm from BMMA1/1 and my metric number will be B0918101999. So today I'm going to talk about my assignment title, which is Desmodromic variable timing. I'm going to talk about advantages and disadvantages of Desmodromic variable timing. So as for the advantage of Desmodromic variable timing, or in a short form DVT, it can be controlled in any engine speed. Okay, and secondly, the overlap valves can be controlled, and controllable torque in various engine speed. It increases fuel efficiency, and engine runs smoother in low, mid, and high resolution speed. That means RPM. Okay, as for the disadvantage of DVT, Desmodromic variable timing, it is high tendency to break, high cost to produce, and high cost to service which is involved so much of costings. Mainly there's many moving components, and lastly it is very complex designs.
Assalamualaikum warahmatullahi wabarakatuh. My name is AQIF bin ANUAR, and I'll be presenting the improvements and the opinion section of the assignment. First of all, the DVT works better compared to the normal VVT due to the structural design of it. And then the next is the wave timing can be suited across all engine speed. So most of the times, the DVT, since it's been manufactured by the Ducati, the DVT has been used across all engine speed, from the MotoGP part, and also from the commercial motorcycle that they produce. Next is the using the lightweight alloy that the DVT possess, because since the metallurgy from like the 20th centuries and the 21st century are very different for each other, so the capability for the material to possess such high heat endurance can be beneficial for the DVT, especially when the engine temperature will be more than regular alloy that they used to back in the day. So it definitely an improvement of some sort. Next is that the DVT can be improved if there were integrated DVVA with the DVT, because the DVVA works the same as the normal VVT, but better, as they can work independently, controlling the size of the valve, which they can opening the high or more medium and low for both intake and exhaust camshaft. Next, that the DVT can reduce engine noise.